Hello and welcome to this Shieldia guide on how to detect the activity we have undertaken in the brute force damn vulnerable web application low security post. This section will cover the detection logic we can employ within Elastic to be able to detect this activity. I would also like to underline what exactly we are detecting and how you can then use that for other aspects in future posts. You will require the prerequisites if you want to follow along at home. You will need the blue team version of the Tartarus lab set up on your local host. If you would like a more detailed introduction to the Elastic SIEM, please also see the previous post on the shieldia.co blog. First, we are going to look at detecting what this activity is, therefore how we can actually detect it. What it's doing, like I said in the red team post, is very much not something you'd want to do in production. However, that does give us a great starting point to be able to look at this for reasons that will be made clear later if it was using a more production ready method like post. We will be hamstrung in our ability to be able to detect this activity without a WAF or another tool to be able to inspect those post requests. However, that's beyond the scope of this video. Here we're discussing, for instance, you had a user, let's say Kogami, at the PSB, and they want to set a password, for instance 2137. How could we attack that? Well, would be a dictionary attack. You take a list of leaked or known passwords and then you apply that to that specific user. In most instances, this would be more shotgun approach over all of the list of accounts as well. However, here we're targeting a specific user, so we will say Kogami at PSB and then the password 2137. In RockU, that would be the 12 millionth line item. However, if we were just doing a request on some random numbers, that would be some sequential numbers, that would be the 21,037th attempt would successfully log into his account. So it's just to say, all of this activity, we are interacting with the target. In that interaction with the target, you will leave a trail and a trace of your activity. Now with the get method, it's much easier to identify. However, in a properly secured application with the post method, it will be very similar. Don't think that will disguise your activity, because you're always going to be leaving a trace when you undertake this activity. We can, if you didn't follow along with the red team perspective, this is the command you would run to generate the logs. However, I have already generated them, so I will not be running that command. In Kibana, so we can log in, advanced, accept the risk, log in. Again, with the steps from the prerequisites guide for the blue team perspective, you will be able to log in. We can see a number of alerts have fired for our attempts. We are only really interested in these Sigma web app alerts that will pop up within the SIEM section of Elastic. You can also see, so we are only really interested in these Sigma web app hack tool user agent, is a good one because that's the default FuzzFast default user agent or Hydra user agent. Detects those. Again, an aside, don't rely on that purely because it's in the attacker's control, etc., etc. Then we say, okay, what is the activity that we're detecting? So here we can also see you will be presented with these alerts from the activity: Sigma user agent and correlation brute force. we can take a closer look at one of the correlation brute force alerts by clicking on the name. That will bring up an inspector. So we will move over here. We can then, unfortunately it didn't format exactly how I wanted to because this would be on new lines. However, we can run this ESQL search. There are some caveats when running the search. Running it via the timeline, which is demonstrated in the blog, is different to running it via the try ESQL as mentioned in the prerequisites and the recon posts. Those, like, they have slight nuanced differences. This is the definition of nuance, but bear with me. We can run the search here and it will give us some information. We're going to say the last hour. We can see that it's sort of formatted like this. However, if we ran the same search in the Discover TrySQL, it will look slightly different. So now in the TrySQL, ESQL, run the search in here, and then it'll be formatted a bit nicer. I prefer this view. However, I'm not particularly attached to either. Just to note, if you see images where it looks like this, it's probably because they've gone through the try ESQL, as compared to this, which formats it like that if you do it via the timelines. So the timeline is how you would initiate an investigation into this sort of activity. So you could take an alert and then integrate that into a timeline of activity that you have investigated. We can see here all of the different, so this is just from the weblogs. This is not anything other than what's already in the system, in the Apache.log, the Apache access.log file. That's all we are looking at here. We can say from that specific index where the method is get. I know we're going to get to that later, pun intended. URL query like username, password, and login. That will then specify any of the URL queries that look like a login session. We're only interested in those. We're going to eval the username to equal a split for around the ampersands. We're going to stats with the event count. We're not doing a count distinct, we're just doing a total count by the username. We're then doing an eval where valid case starts with username. So that's where the split comes in, the eval split earlier. Where valid, so where it has that username field. Sort by the attempt count, and then where the attempt count is greater than 10. This will then give us, for some of these accounts, 20,000 attempted logins. For other accounts, maybe only 7,000. So it gives you an idea of how we can use this ESQL to, just from that alert here, say, okay, well, how do we go about investigating this particular alert so that we can identify malicious activity that may or may not be occurring. That is just the search that I ran previously. Now moving on to Sigma rules, which is how these rules are integrated into Elastic. It is a really powerful resource created by the man, the myth, the legend, Florian Roth, to be able to interchangeably use SIEM rules on any platform. You would write the Sigma rule and then it would basically compile to that specific SIEM language through however the operators work, through however, does it have correlation rules? Does it not have correlation rules? What specific formats? All of that stuff you can then define in a Sigma rule. We will take one for example. It is, if you want to understand more about Sigma, you can read it from themselves. Or if you just want to see how a rule would operate, this is a very simple rule that I wrote in regards to doing an audit of all of the MITRE ATT&CK techniques that are and aren't available within the Sigma HQ repository, because I wanted to create a compendium of Sigma rules to map directly to the MITRE ATT&CK technique IDs. It's a long-winded way of saying it's still in the pipeline, but this is one of the rules. You can, within Windows, create a user with just the $sign that will then be a hidden user, not visible within the main login screen. So if you wanted to then do all of your activity, your nefarious activity, under that new hidden user, you would be able to, and not be so easily picked up by an end user, because it's not going to be presented within that login splash screen. So the history of the rule. Now, what are all of these fields? You have the metadata fields. Title is one of them. The ID is a very important field. So then that's a globally unique ID. So when you implement this into a SIEM, a lot of them would tie that to a UUID v4. So then that's tied in. Then there's some other optional fields like related. So we can say related and then the type. Is it a derived? Is it a similar? Is it a supersedes? I don't think that's specifically one, but there is one that I think you can supersede. The status, experimental, test, production, all that good stuff. Then a description, so a meaningful description of what the alert, once it's composed in the specific SIEM language, would entail. Some references. I'm aware it's not good practice to be like MITRE ATT&CK technique IDs or the Atomic Red Team, but for now, this is just within my repository. This isn't in Sigma HQ's primary repository, so we'll go with it. Author or authors, so it's a single or an array of authors that have authored the rule. The date, this is incorrect. It should now actually be hyphened, but that's neither here nor there. The tags, so the MITRE ATT&CK techniques and IDs, you can then include them within the tags field, and then that'll go through and decompose that into what you could see here when the alert has fired. There's MITRE ATT&CK, and then this is not, of course, the same rule, but the principle is the same. It'll decompose into an explorable item for an analyst. The log source, you should rarely be specifying which log sources, because then that helps with pipelines and stuff later on. So here it's Windows, the security subsystem. Then finally, the important part of it is the detection. So what are you telling this rule to look for? We're going to say detection, selection, event ID of 4720, which is the local user created. There's some great resources that you can use to explore these specific event IDs. Then the target username, specify it to be just a $sign. So we're not doing any regex, so it's not a meta character in a sense. It is just look for any that are just a $sign. And then the condition. You could say condition selection and not some set. You can do a lot of different stuff in the condition section. However, here we're just doing condition look for selection. False positives as well, and level. The level will then be decomposed. For instance, in Elastic, it gets decomposed into the severity. So medium, high, low, critical, that sort of thing. That's where the level would come in. That's what we've just explained. You can then, of course, go look at one of the compendiums, and then a user account was created for that specific event ID. Then with something like either the Sigma CLI or the online Sigma Converter.io, because I'm no longer friends with the other one, you can, using pipelines and the specific Sigma rules, be able to convert this into the language of your choice. So here, for instance, it is taking the specific Sigma rule. We are specifying the target language to be Splunk, the format to be default, and then the pipeline to be Splunk Windows, because that has specific field namings. And then it says, okay, cool. This is the search that you can now run within your Splunk instance to be able to search for this activity. It's a bit more difficult within Elastic because we have some pipeline files, because then it renames some fields, but we don't need to worry about that at the moment. Now, a more advanced use case for this is the rule to be able to detect the activity that we've undertaken within the Red Team section. This rule is a bit more complex, or much more complex, but I'll go through it. We have the title, we have the ID, we have the status, same as before. Now we have a name field. I specify the name field here because it's actually a multi-rule separated by the YAML file separator. We then provided a meaningful description, author, date, again in the correct format now for updated Sigma rules. Modified is an optional field. If you made changes to the rules, you understand, when was this rule changed? It was 3 days ago. That's why it's not working, etc., etc. Tags, as explained before. Log sources, this is a much more specific log source. It's saying category, web server, service, access, product, Apache. So it's saying specifically the access logs for the Apache process in the category of web server. Now the detection, again, we're stating the selection and then which fields within there. So we want to say the HTTP request method being GET, the status code for that request being 200, URL, so this URL field has to contain, so doing more regex or wildcard matching, all of these, because it would normally be an or wise, we want it to be and wise. So we say all of the following: username, password, and login. Then we specify the condition to be selection. Finally, the level to be medium. That will then, through the pipeline, be composed into whatever numeric value will be in the backend of your specific SIEM. With the file separator, we then state, because that's just the base rule, we want more granular control over this. We want to actually say if it reaches a certain threshold, then fire the alert. We don't want every single request like this to fire an alert, because that will just exhaust everyone's time, and we don't need that. Instead, using a more advanced technique, the YAML file separator, we can have multiple rules within one single file. This could be separated out into base rule, correlation rule, threat hunting rule, or through the file separator, it could all exist within one rule. If your specific SIEM does not support correlation rules, that is no stress. You just remove everything after the first triple dash and the triple dash itself. Then it will just be a rule for that specific condition. It's not perfect, but if your SIEM doesn't support it, there are ways and means around it. However, if your SIEM does support it, then it is a very powerful tool to say, here we're saying, again, log sources, condition. So we're not saying the detection, we're saying a correlation rule. The value of value count, the specific rules. Here you could have multiple rules and you can make these things quite complex. We're just going the first base rule. We then want to group by client or source IP and host or destination target. We're then saying the time span in 1 minute. Condition greater than or equals to 20 of those searches within 1 minute by the URI query field. False positives, again, unlikely, and level. So that is the rule. Then there's another, because I just wanted to be a bit more, wanted to understand, truly understand these things. There's another one which is a threat hunt, that the pipeline based on the specific name doesn't actually apply, like I spoke about previously when looking at the pfSense rule that wasn't correctly applying. There are Sigma rules within the Tartarus lab that don't actually get turned on. We can see here all of those are turned on. However, these threat hunt rules at the end are not enabled by default. You can enable them, or you can just look at them and use them to run a retro search. So you can see here are the names of those rules and then what they would do. They're not enabled by default because they would just be way too noisy, but they're there in case you need them or want them. So that is finally another file within this YAML file to say threat hunt correlation rule. We're going to say greater than or equal to 10 over the time span of 1 day, which is much larger than, and this would generate a lot of noise, hence why it is disabled by default. Going over what has already gone over. What happens If you do not have a SIEM, if you do not have all of this, or you want to confirm locally to that specific targeted resource within your environment, there is the side channel, SIEM, no problem, which goes through how you might investigate these things from a little bit of a incident response side. How, or you'd be telling a sysadmin, run these searches, please send me the results. This is the same time. We're going to want to SSH into the damn vulnerable web app Ubuntu machine. You can do that via two methods. You can either use the Kali box and SSH in, or you can, from the terminal you ran Vagrant up from, you can also SSH in there. So I'm going to projects, Tartarus, tab, completion again. We can then say Vagrant status to get the running metrics on all of these boxes. You can see OpenSense is running, the Elastic is running, damn vulnerable web app, and Kali are all running. Great. You'd need them to be running to be able to run. I'm going to some other trickery. You can do this, replace status with SSH, and now damn vulnerable web app. So within Bash, there are some terminal wizardry you can do, which is with the within Bash there's some other terminal wizardry you can do, which is the cache character. If, for instance, I want to get the running status of a process, so I'll do actually, let's start from the beginning. We're going to do, no, but you don't actually need that for that command. So okay, we'll do sudo, wait, we're going to do systemctl status for SSH. So this will give me the status of that SSH process. Now, let's say I didn't run it with sudo. You can do sudo bang bang space. Then that will run the command with sudo. And then you'd have to input your password. Now it's running with sudo permissions. However, let's say this is a bit of a diatribe, so don't stress. Let's say, for instance, we've run this, but we want to then say status into something like restart or some other command. You can do that simply. Be very careful with this, but you can do it simply with the cache command. So the word you want to replace is, let's say, SSH. I want to replace with some other running process. So in this instance, we can do cinnamon. We can do, so just to confirm that, cache SSH and then replace it with some other service. So what would be a good service to init? Init service, init FS and all the other services. Okay, but you can see there it's then replaced SSH with another service. So you can do that to more easily replace these commands as you run previously. All that to say, Vagrant SSH download web app. Now this will use the SSH key that was generated at runtime to be able to SSH into that guest from your host system. Here we can then tail the Apache access logs. So it would be in var log Apache 2/access. Normally var log would be in its own mount point with an expandable file system, but we're not going to worry about that at the moment. We can see here tail has printed out some information for requests that have been made to the system. Here is using a Elastic, because we have Elastic installed in the entire environment. This is just doing a health check to make sure that the web service is available, so that if the web service goes down, there's some other alerting logic that you can do in the back end of Elasticsearch or Elastic Kibana. So let's say we want to access the web server. We can with a simple get request, and then it will populate within the logs So again, the up arrow to down arrow, up arrow to cycle through the command history of that specific guest. There you can see here, that is my Firefox or Mozilla user agent trying to access the service. Great. You can also do like a tail F to follow it and that sort of stuff. We're not going to worry about that at the moment. Instead, what I would like to demonstrate and explain is the breakdown of these, because one of the things you have to understand this stuff. You'll get there, but you have to understand it. This is just a little image I threw together to explain some of the fields within a Apache access log from Apache's documentation. You have your source IP address. You have stuff that's not actually used really much anymore. The two hyphens would be like a user account, and then so like a local user ID and then the user account. If HTTP auth is used, it's not really used that much anymore, so we don't have to worry about that. But the next field is the timestamp, and then they're specifying the specific RFC that timestamp would conform to within the square brackets. Then in the quote field, so it's because it's client side information that's coming into your logs, it would normally be quoted, because you could replace that method with any method. The server is probably going to go, it's not a supported method, but that method could be anything. Similarly, that specific file path could be any string that the client sends to the server. Again, the HTTP protocol could be anything that the client sends to the server, so it'll be within quotes. The server's response is then recorded. In this instance, 200, okay, it's found. The size of the response is also noted down. So it's a variable length size that will be sent to the client that is requesting this resource on the remote server. If you were referred from somewhere, it would be in the referrer header. That is also quoted because it's something that the client controls. Finally, the user agent that made the request. There are other things that may come later, but for now, we're not going to worry about that. The user agent that made the request. So let us, with this knowledge, go back to the search that we just did and have a look. We can say, yes, the Kali instance, me, made that request. We aren't using any local auth or any of that stuff. Great. The timestamp in square braces. Get the specific resource, which was the damn vulnerable web app subdirectory. We are then presented with a 302, which is a redirection code to tell us, don't go here, go somewhere else. The size of that response, the referrer header, which is empty, and then the specific user agent that was used to make that request. Then, because it happens automatically with a 302, the browser goes, okay, get this other resource that they're telling me to get. So we go to the login.php. That's then responding with a 200, and then use the specific size of that response. We can then use all of this information to be able to search for that malicious activity that we have undertaken previously. We can say within the correct window, close the image. You could do this as from the specific terminal that you ran Vagrant up from. You do Vagrant XSH and then give it a command, or you could just copy out that command itself, which is what we will do because we've already SSH'd into the server, so we don't need to worry about that. This will then get all of those responses that match that specific grep. To explain it, we'll do sudo, because depending on the permissions and stuff like that, we just run it with sudo. Don't worry about it. Grep, and then we're going to say to use regex. We'll then say get, and then a wildcard matcher for the specific password field, then another wildcard matcher, a space, and then the 200 response code. We want to then only output, we don't want to output everything, we only want to output what this would match, and then the specific file we're looking in, which is the Apache access logs. Then that gives us all of these requests that have happened throughout our brute forcing attempts today. There's more stuff we could use. If we wanted to sort it, we could use something like awk and then give us more statistics around what has happened. So we can see the source IP address of that has attempted almost 60,000 of these attempts today. Have been, well, through the lifetime of that specific access log file, which is normally controlled via the syslog log rotate. So it'll be maybe every 24 hours you get a new file, but that depends on your specific local environment. Here it's throughout the lifetime of that specific file because it's such a small environment and we're not using any log rotating stuff. So don't worry about it. Here we're saying awk the 0th, providing it with some regex, which is the same regex we did before. We're going to then print the first returned field from that. In that specific file, we're then going to sort it. We're going to count the unique, and then we're going to sort again so that we get the number of rows. Yeah, the number of rows. So that's one way you could do it with awk, and then some sorting and uniques. Now, if you wanted to, you could integrate that with an ad hoc search via Ansible or via any other applications that you have. You could run these things in an ad hoc basis across your estate of web servers so that you'd be able to get the responses and see, are people trying to brute force in? Of course, this is a non-application led defense that you could have, not necessarily a defense, but a search that you have to be able to detect this type of activity. There are other approaches you could do, actually securing the application. However, if that's not possible or practical in your specific environment, these are some other methods that you may employ. However, I would highly suggest just secure the application. And then finally, there's the purple team, which will be covered in the next video. Thank you for joining me today. I hope you learned something, and I will see you in the next one. Hello there. Welcome to this episode of the Shieldier Guide, or this part of the video. We're going to look at the Damn Vulnerable Web App brute force on low security from the purple team perspective. We're going to cover in a bit more detail a more advanced nuclei template, and then we're going to cover how we can use the Omega CLI to simulate this activity within our environment. First of all, if you follow along with the blue team part of this video, you're going to need the blue team setup, the prerequisites, make sure your host meets the minimum requirements and all that. We're going to then use a nuclei template, so you're going to need that installed on your Kali instance if you're using the Vagrant lab. Here it's a bit more of a complex template file. We're defining, as stated previously, the ID, or how it gets printed to the screen. We're going to then define some metadata about the rule. So damn vulnerable brute force low sec authenticated, because this has to happen after you've authenticated to the damn vulnerable web app so that you can get to the brute force challenge. Then author severity, that sort of stuff, don't need to worry about it. We have two different methods of declaring variables. We have the key value pairs here, password equals password and username equals username. This is going to be used to log into the application. It doesn't have to be, you don't have to define variable like secrets this way. You can use something like HashiCorp Vault, and then at runtime, when the specific template executes, securely fetch that secret from your secrets store. That is the preferred method. However, we're not in enterprise, we're in a little lab, so we're not going to worry about that. But Nuclei does provide that functionality, which I highly recommend. If you're going to make this production ready, you use a method like that to secure your secrets. Always keep them secure. It doesn't matter if, oh, it's just a dummy account, it's just UAT, blah blah blah. Keep your secrets secure. Keep it secret, keep it safe. Then we're defining an array of variables to test for, like how we did in the red team part of this video. We tested each individual username with a dictionary of passwords. We're going to do something similar here, where we define one username and then an array of passwords to test. So we have admin, and then all of these passwords will be tried against that admin account until one succeeds. Moving on, you'd have leet, then you'd have all of these passwords be tested against that account, etc., etc. We have the flow section. This is more in line with a modern V3 template. We can, in the first part of the flow, use that to log in to the application, and then using the double ampersand or similar syntax to what you'd use within a shell like bash, you then supply it with another HTTP. So you see here, HTTP 1 would be this raw request, and you can see these are arrayed together. Then this is the second HTTP that would happen. So the first one, you get the web page, and then that gets for that session a user token. Then using that, we extract the user token. We can use that user token as well, and the username and password to log in. Username and password are the variables defined up here. So it'll use admin and then password. It will then go on to the next step if that step succeeds. If it fails, much like in bash, it'll just boop, that's it, no more, with the double ampersand execution, as opposed to the double pipe or the semicolon execution. Those have different flow operators. Here, it will only if the first HTTP succeeds, it'll try the second HTTP method or protocol, as Nuclei would call them. It is going to then do a post request. We have to extract the user token because that is how it is keeping track of which users should, or which instances should be at what security level. So instead of the original Nuclei template that I showed you in a previous video on how they are changing, manipulating the cookie headers in flight, this is going to do it like you do in a browser, where you go, okay, I've logged in, I'm going to then manipulate for that session the security level. So we set it to whichever level we want. In this instance, we'll set it to low. Finally, step 3 executes the brute force attack, but this is just providing a template for how the flow will execute it. So here we can see, because we're using the get method, it'll use get and then our directory where the login page is located. Then it will use the variables with something like as a mustache or machete variable substitution. So here, I'll show you in a bit where they come from. And then some more logic. So stop at first match. You have to set that to true or else it will try everything. We're not trying it like later on I'll demonstrate some more fuzzer-like or more brute force, battering ram, pitchfork, that sort of stuff. We're not doing it that way because I found this to be, for these specific tests, the most stable. That's the primary reason to do it in flow as opposed to with an attack method like pitchfork or battering ram. We have the match condition as opposed to what we did with Hydra. We're not excluding pages and then going whichever doesn't have this. Instead, we're going to positively match. So if the returned message body contains the string welcome to the password protected area, and then it'll be their username, but we don't care about that at the moment. We just want to say if it says welcome to the password protected area, bang, then we successfully logged in. Finally, we have an extractor. This will then be able to print that. Because we're not using the traditional attack methods, we can then extract the user and the password to print to the screen to say, this user with this password successfully we brute forced and logged in. Here we can then run this template. So I will go, and there is actually that just explains what I've explained. Here is the command to run it. We can then log in, or have I? Then we can run it in the Kali guests shell. So you could just paste it into a normal terminal, Control-Shift-V, and then to explain, nuclei is the command we're using. You're gonna have to get that installed. Sudo apt install nuclei. Then U for the URL, which is the target. We don't have to specify the full path because that's already taken care of for you in the template file. Then you pass it the specific template file. Here it's not going to be a relative path, it's going to be an absolute path from the root directory. So it's going to be under Vagrant, Nuclei templates, down on the web app, and then the specific template file you want to use. That's already located for you. It's all done. All you have to do is run the command, and then this will come back with information as to, boom, succeeded. So you can see here the name that we specified in the template file, the method, the protocol that it's used, which is HTTP, the severity, the target, so it prints out the exact URL. Then it says with the extractor method at the end, username admin and password, username leet, and etc. etc. So now we have successfully used this nuclei template to simulate a brute force attempt against the damn vulnerable web app. Moving on, we would then be able to see those alerts within the SIEM. So I'll log in quickly and then we can have a look. Don't forget that you'd have to wait at least 5 minutes for the alert to properly trigger. You can manually trigger the rule to fire and then pick up the activity that we've attempted. However, you can also just wait for at most 5 minutes and then you'll be able to view the alert in the Elastic Kibana alerts dashboard. For example, here we can see the activity that we just undertook with nuclei for the brute force attempt, and it successfully picked up our activity. Now, if we wanted to do that in a bit more programmatic and a bit easier way, we can then use the Omega CLI. Scrolling down to the section regarding the Omega CLI. So this test it's a nuclei template test. So it's just running that nuclei template in a structured manner. Executor as nuclei, the specific templates with a relative path, then the specific rule that we want to test against, which is a SIEM rule ND-JSON. It's the exported format from Sigma, but you have to do that export outside of the specific template execution for now. In future, I will integrate that where you could run it via a Sigma rule and then it will do that conversion for you automatically on the fly in the template file. However, at the moment, that is not the case. We then also have some info about what we expect the test results to look like. So now you can copy the command to run, and then moving to the Omega directory where you've downloaded it to on the Kali instance, we can then run this test. So here we can see LH, we can see that I have my N file, which has all of the security details, the certificate, the API key, all of that in it already to be able to log in automatically via the API to Elastic. In production, I am aware we wouldn't want it in an N file. We would instead want it in a secrets store. 100% agree. However, this is just a lab, please. We're going to paste that Python 3 Omega config to read it from the .m file, the specific test that we want to run, which I demonstrated earlier in the web page, and then the connector, which is the Elastic Local as opposed to Elastic Cloud, then the target that we want to run this against, and finally the debug flag. Now this will, as you can see, it has completed the nuclei template already, successfully logged in. Then it will now wait for data to be ingested into the Elasticsearch instance before it runs the search, which it should run now. There we go, successfully tested, all done. Now you can make tweaks and changes to these rules as opposed to, and then just rerun the template file, as opposed to rerunning this template every single time manually like we saw with the nuclei in the beginning of this section. So that just makes life so much easier. And that is all for today. Thank you for joining me. I'll see you in the next one.